What is up, second block? All right, you guys got to finish your lab report, and there's two sections we got to talk about. That's the error analysis, and that's the conclusion. If you go to our course homepage, click on the portfolio assignments, then you can see Parking Lot Biodiversity Lab. That's where we're going to find these resources. When you click on the lab report format, that's when you get this sheet. And so we need to talk about the error analysis and the conclusion. An error analysis is not all the reasons why your experiment was bad. An error analysis is the source of scientific uncertainty in your data. You know, every time when you make a graph in a science class, you know, the data points kind of bounce around, but you can make a line of best fit. Well, an error analysis talks about why do the points bounce around? Why is there some uncertainty in the data? Why does the data bounce around? And if you think about collecting the data for our experiment, there could have been some uncertainty in the way that people count the cars. It's really easy to miss a car as you count, or people could have classified cars differently. And so there's some just a natural uncertainty in our data. It doesn't make it wrong. It just means that there could be some natural variation in it. So when we talk about our error analysis, we want to talk about the reasons for variation and what we did about it. Those two things must be in there. So for the source of variation, we could say that there could have been some differences in number of cars counted based on missing a car or misclassifying a car differently. That would be the source of variation. What we did about that was that we had multiple groups counting and we took an average. So there's the uncertainty, there's what we did about it. Another source of uncertainty could be people coming and going on the parking lot. And we could do this experiment lots of days and then take an average over a number of days to reduce that uncertainty. Or we could just make an assumption that the people leaving would leave in the same ratios as the cars that exist in the parking lot. And so if the people that were leaving or skipping were randomly distributed, it wouldn't affect the ratio of cars. And so because of the similar ratios, it wouldn't affect the outcome because we weren't counting the whole number, we were actually counting the probability in our measurements. So with our error analysis, it's what could cause some uncertainty and then what did we do about it. Then there's the conclusion. The conclusion paragraph is where you've got to write a paragraph that flows with good sentences, and it addresses the topics that I give you, the bullet points. You don't have to write it from scratch, which is what real scientists do. When they do an experiment or they do a research project, they've got to draw their own conclusions. But we point you the right way with the bullet points. It's important that you just address all the bullet points in the conclusion paragraph. So I've got me a copy of the conclusion paragraph. You guys need to follow along on your own lab sheet. And so it says, summarize your results for the 3 calculated indices in narrative form. So the first bullet point, just give the answers that we got for the richness, give your answer for the Shannon-Winder index, and give your answer for the evenness for the student parking lot and for the teacher's parking lot. Just say what your answers were for the first bullet. Then the next bullet says, is there a significant difference in diversity between the two communities? Well, let's look at our numbers. Okay. Here's our second block numbers. What we see is that the teacher's lot is slightly more diverse than the student's lot. Our numbers are higher for the Shannon-Winder index and the evenness, and so we could cite those numbers as being higher. And so we could say that the student lot is slightly higher, the teacher's lot is slightly higher than the student's lot. The third bullet says, is there any evidence of disturbance in our data? Well, here's something you need to know. When a community is disturbed in nature, that might be a forest fire or a hurricane comes through and clears a lot of stuff out, you'll see a big drop in diversity. or if there's a major pollution event or something like that, the diversity will drop, and there'll be a big drop. And even though there's a difference, I wouldn't call that a big drop in diversity. And so we will say, no, there's not a significant difference because there's not a significant drop in our indexes. What would be a disturbance according to this model? Well, what would change the cars that are in a parking lot? Well, think about what we've had recently. A snow day would certainly change the cars that are in a parking lot. A teacher work day would change the cars that are in the parking lot. Here's one to think of for yourself, and hopefully this shows up in your lab report. What kind of events would maybe have a lot of students at school, but maybe the teachers have gone home? What event would fit that profile? And that would be a disturbance in our model that would change the makeup of the cars in the parking lot. In real life, we just talked about some of those disturbances can be forest fires, hurricanes. Something major, though, that really changes the landscape and the abiotic factors especially. And then finally, did any species dominate in our community? Okay, now everybody's going to be tempted to say the four doors dominated, but be careful about that. Dominance means two things. A, there's a lot of them, but B, it holds the other guys down. And what we can see, particularly with the SUVs, is that even though there's a lot of four doors, there's still plenty of SUVs and then there's even trucks in the student lot to keep that species a little more distributed. Also, look at our evenness number. Remember that closer to 1 is more even, and closer to 0 is one species being more dominant. And if you look at our numbers, yes, they're not quite 1, they're actually significantly away from 1, but they're closer to 1 than they are to 0. And so what we're seeing here is that there's not dominance. We might call the four doors common, even though the four doors would be considered common, they wouldn't be considered dominant. And so those right there are the bullet points that we go through for the conclusion, and kind of think about how you could support any statement you make in the conclusion with information from the data. As you do your lab report, make sure that you have all these sections in the lab report. Remember, this handout is on the assignment page, so make sure you follow the handout and you've got a title, an abstract, a purpose. When we talk about suggestions for further investigation, there's not really a right or wrong answer. Just try to come up with something else we could study about the cars. You know, take the cars, what other research question could we ask to drive an experiment? Make sure you've got all the data sections. Make sure you've got the analysis in there. So yeah, anything on this handout, make sure you have on your lab report. Hopefully this little discussion about the error analysis and conclusion helps point you in the right direction on those.